Oh, we're good. Recording has now begun.
Sounds good. Well, folks, we'll get started here. I know a few folks usually tumble in a little bit after the hour, so let me just kind of start us off and kick us off here with what our agenda is about. So this is our 8th Tech Talk session. We've worked our way through quite a few of the services. We worked our way through all the core services, how to get things up and going, both in development and as a user. Now we're kind of pointing our way up towards the top end of EdgeX, which is what are called the export services. That's the topic here today. So on the agenda today, we'll talk about what exactly does export services mean. We'll find out that really is a couple of services, client service as well as a distribution export service. We'll also find out that really this is what the connection to external systems as well as to things like rules engine and analytics typically is going to reside in our EdgeX system. We're going to talk about what technology is used to make this particular set of services work, what the basics are around it. We're also going to find out that there's a key ingredient to this particular set of services, something called Spring integration as a technology, and maybe even more generically, something called enterprise application integration. We'll chat a bit about that. We'll look specifically then at what export client and export distribution are made of. We'll look at the data model underneath the covers, the APIs. We'll look at some of the technology and how it works and a little bit of code as well. We'll take a look at a small little demo so you can see how some of these export services work. We'll take a look at some configuration settings that are a bit unique to export services, and then we'll wrap up with a little bit of a discussion about what's coming in the future for export services that the applications working group is putting together, and we'll wrap up with some Q&A. So that's what's on tap for our hour here today. So big picture again, when we're talking about export services, we have these two blocks at the top of our now famous EdgeX diagram, client registration and distribution. That's what we're talking about with regard to export services. Yep, we've got these blocks over here that say additional services. There's nothing there today. We'll talk about what might go there someday in the future or might go there as a result of some of the work you all are doing out there that would be add-on value to EdgeX and how you can start to tie things like analytics into the picture. You'll notice here I've got two big blue arrows. Those are really instrumental as part of this export service as well. The arrow to get data off of the EdgeX box up to your cloud systems, your enterprise systems. If you want to have EdgeX take device and sensor data and get it off to something like Azure IoT Hub. This will be your mechanism to do that. And you'll also see that there's an arrow coming out of the export services back down into EdgeX, and in particular into things like the rules engine. Again, other analytics engines may apply here. We'll chat a bit about that and see how EdgeX essentially prepares data for these kind of local edge analytics to take advantage of and use to do things like actuate back down onto devices and sensors. So that's the big picture. Those are the two services we're going to be talking about. So export client and the export distribution microservice. Again, providing the ability to get the data from our sensors and our devices to other either external systems, again, like Azure IoT or Google IoT, or to get data to things like our local systems that might be doing some sort of intelligence on them. In this case, we've got built into EdgeX today a rules engine that is a recipient of that data. But it could very well, as I mentioned, be other analytics or edge intelligence, if you will, that you build out. Again, that's that spot for those other applications that we talk about in the diagram. So when we talk about export client, we mentioned the fact that this is a facility that is export services, a facility to get data to both internal and external clients. What do we mean by that? Well, it's the export client microservice that provides a registry mechanism for any client, be that an external client like an Azure IoT hub system, or say an internal client like the rules engine, to register itself with interest in data coming off of our sensors and devices. And when you do that as a registrant of the data coming out of EdgeX, you specify what it is you want and where you want it delivered. So for example, you might tell EdgeX through this export client that you only want to see temperature data. and you want it formatted, say, for example, in JSON. You want it filtered, again, only being temperature data. Maybe you want it filtered to be only temperature data coming from particular devices. And then you specify where you want it delivered. Do you want us to deliver that data to you via HTTP REST endpoint? Do you want us to deliver that via MQTT topic? So as part of the registration process provided by the export client microservice, it's about where you want the data, how you want the data, and where you want that data shipped to in terms of registration process. On the export distribution side, the export distribution microservice is what actually delivers that data based on all of the registered clients set up via the export client. So it's the distribution mechanism, the distribution microservice, that's really doing the heavy lifting with regard to getting all the data out of core data, actually being a recipient of all the data from core data, getting that data transformed into the format that your clients want the data in, filtering that data, doing any other work that it may need to do with that data, such as maybe encrypting it or compressing it, and then sending it out to the actual endpoint that the clients have registered themselves for. So it's the export distribution services we're going to see that is really the worker bee amongst these export services. More on that coming up in just a second. So in our export client facility, in our export client microservice, what's at stake here? What's actually performing the actions of this microservice? How does it work underneath the covers? Well, it's a very simple Java Spring MVC application, folks. It provides a REST set of APIs, and as you'll see, that REST set of APIs is really just around one resource, and that's essentially a client registration resource. It does connect to Mongo database in order to store client registrations. So if you're a client out there, I've got it shown here in my diagram as a person, but obviously that could be a system, some application, could be something you've got in the cloud. You would register for an intent, for a need for EdgeX data with client registration, and that data then gets persisted into a database, in this case to the Spring Mongo database. We could use any other kind of database we'd like. It just so happens that for all of EdgeX, we're right now using Mongo as our reference implementation behind the scenes to store things like our core data and our metadata. It just seemed appropriate that we reuse that core database instance, that export database instance, if you will, goes into a separate collection in the Mongo database. But this service is completely independent from all other microservices, including export distro. In other words, it can come up on its own, it can go down on its own, it can be replaced on its own, and the database that you choose to store the data the export client is going to actually have to maintain could actually be swapped out for some other database as well. In fact, we've got a company that's part of EdgeX, Mainflux. Janko Izidorovich is the chairman of the applications working group that's actually in charge of these two services. And they're actually doing some work to improve the export services, but they're also doing work to replace, in particular, the export client with a Go version of this same service. So again, it is an independent microservice like all EdgeX services are, but this one in particular really is fairly simple and just about registering clients for the need for data coming out of EdgeX. A couple of other notes that I'll make here. Yes, there is a bit of a dotted line here between the database of export client and export distribution. And as you will see, export distribution has to go grab all the client registrations as it gets ready to distribute the data. So there is that one connection point, but that's really not a connection point at the export client microservice. It's about the data underneath. Another point I will make too is, as you would anticipate, a registration system could easily use a graphical user interface around it to help those clients register their need for this data. And in fact, Dell, when we were building Fuse, which became EdgeX Foundry, we actually did build an Angular 2 web application around the export client facility to actually allow clients to more easily register for that data. If you're interested in that particular UI, maybe you're thinking about building your own, send me an email. Be happy to share some of the information we have about that. In fact, someday we may actually push that out into the open source and contribute that. It's just a matter of getting that through legal and getting some of the Dell branding off it. But if you're willing to sign an NDA, we might even be able to get you that code. So let me know if you have particular interest. Certainly could talk you through some of the aspects of how to build your own UI there. Now, the export distribution services I mentioned, that is the microservice that really does the heavy lifting in the export services. So what does it work, or how does it work underneath the covers? What's the technology involved here? Again, it's a Java Spring application. In particular, though, what this takes advantage of is a Spring technology called Spring integration. If you haven't used this framework before, this is really a great enterprise capability, and we found that this was going to really help us to kind of short cycle our development of this particular microservice without having to do tons and tons of extra work. Having said that, it is a pretty beefy framework, and so going forward, one of the things we may have to look at is could we maybe shrink this technology down a bit. Now, if you've never dealt with what is known as an enterprise application integration framework, I highly encourage you to start to research that before you get into the bits and bytes of the export distribution. You can work export distribution without knowing everything about Spring integration, but if you want to add to it, if you want to debug it, if you want to get in there and start to think about how it works and how you build a supplemental service of some nature, you're really going to need to understand this type of technology called enterprise application integration. And in particular, there's a set of patterns, very famous set of patterns around this called EAI patterns. And I've provided a great link to a website that'll describe those to you and describe the whole aspect of EAI and EAI frameworks. You're going to need to know those in order to be able to work in this environment. Spring integration is considered an implementation of these EAI patterns. In fact, a pretty detailed implementation from everything I've seen. If you're trying to understand a little bit about what enterprise application integration is all about, it's really about what we call a pipe and filter architecture, if you've ever heard that term. Essentially, you have some data, it gets put into a sink, gets piped to some sort of utility that mashes on that data, pushes it to the next sink, then another pipe might pick it up and do some more work on it. If you ever use something like a grep facility in a Linux or Unix environment, that is really a pipe and filter architecture at the simplest form. So if you're not familiar with pipe and filter, not familiar with EAI, take a look at those technologies before you get too detailed into this particular microservice. So it's what does the heavy lifting underneath the covers of getting data to either external or internal clients in our EdgeX system. Now, where does it get that data? Well, it gets the data from core data. And in particular, it gets data out of the event and readings collections that are stored in Mongo via core data. As data comes up from a device or sensor and it hits core data stores that in Mongo and then immediately creates a 0MQ message that it pushes out to export distribution. That starts this pipe and filter architecture. That starts this EAI engine to take that message and now get it ready for distribution to all the various clients. And when it does so, the pipe and filter mechanism as part of the EAI engine here allows for each message to be looked at. It could be filtered out. For example, it could filter out either irrelevant data that you're not interested in, or maybe data that's not correct. For example, maybe the device ID or the information about the value descriptor doesn't align with what it sees in that message, in which case it could filter that data out. It provides for transformation of the data. In particular, EdgeX export distribution service today allows you to transform the data into either XML or JSON format. It allows you to additionally or optionally compress the data, another type of transformation, or even encrypt the data with one very simple encryption algorithm today we'll talk about here coming up in just a bit. And it's at this point too that we could add in all sorts of additional transformations, filters, enrichers. Anything that's in an EAI pattern can be accomplished via this particular service. We'd have to add some additional components to do that, but this is what allows for a very rich environment to get data to customers as they need in a particular format and in a particular way. At the very end of this process, the export distribution takes the data that it's filtered, it's transformed, that it's compressed, encrypted, all the work it's done to those particular events and readings coming out of core data. It then pushes those out to the registered endpoints based again on what the export client has said for each client. Today we support REST, MQTT, 0MQ. There's no reason in the future we couldn't associate or allow for other types of endpoints, maybe a DDS endpoint, or maybe we want to do some sort of secure endpoint, which we'll talk about coming up at the end of the discussion today. So export client is all about getting the data, or getting the client's needs, the either external or internal client need. Then distribution is all about getting that data when it starts to come in through core data to those various clients. So underneath the covers, kind of a pictorial that maybe helps to give you a little bit of better understanding about how export distribution works. Again, data comes up from sensors and devices through core data. It then, as soon as it comes into core data, it gets pushed into a 0MQ topic. And this is a topic just between core data and the export distribution microservice. A listener on the export distribution microservice picks up those events and the readings out of core data from that topic, and then starts the process of doing its transformation work, doing its filtering work, doing its compression, encryption, whatever work it needs to. So there's a whole set of various utilities out there that the Spring integration engine provides us to do that work. Now, one important thing that we need to note here is there is a step between the pulling of the message off of the 0MQ topic and then starting it down this pipe to do its work. And that is, we have to actually copy the event reading for each one of the clients that's registered. Remember that client registration microservice out there allows clients to tell us where and when they want the data. Well, we have to essentially create a copy of that message that comes in so that we can transform the message to that particular client's needs. If I did everything that everybody wanted, that could be a lot of messages. So one thing we have to be concerned about a little bit with the export distribution service is, depending on the number of clients you have that are registering for this particular data, this system could get overwhelmed pretty quickly just in trying to satisfy all those needs. It is an edge system running at the device sensor location. So hopefully there aren't tons and tons of clients that are making requests out of this box. But if you start to exceed, what would be kind of a rational number of clients, and defining rational depends usually on how much data you've got coming through the system, that could actually push the bounds of what EdgeX is able to do. So once we've got this process coming into place where data is flowing in from core data, it's getting copied and now being prepared to be sent off, what exactly happens with that data, with those events? Here's each of the little steps that goes on inside of the distribution service. As I mentioned, it comes off of the message topic, it gets copied. Well, right before we do copying, we do a check too, an optional check to see, is this data coming through actually still valid? There are cases where maybe the data is not valid. It maybe falls outside of parameters that we've set up for collecting data from a sensor. Or maybe the device ID is no longer valid because maybe the device got destroyed out of metadata because it got yanked off the system. So we will do a validity check of the data. Then we copy it again once per each client that we have in our client registration. At that point, we filter it by devices that maybe a client has said they want interest in. So if I only want thermostat data from a particular device, then this is where data that's not for that thermostat gets peeled off and ignored. I filter by value descriptor. I only want temperature data. If it's something to do with humidity, well, then it wouldn't make it past this filter. Then we branch off based on how you want your data formatted as a client. If you want it in XML or if you want it in JSON, there's a particular transformation object in place that'll take care of that for us. Then we take care of optional compression, take care of optional encryption, and then based on your client registration, we push it out again to the various endpoints, by various objects that deal with the different types of endpoint mechanisms we have. Again, REST or MQTT or 0MQ. So this is what really describes what, again, is that pipe and filter architecture. We essentially have one big long pipe and lots of little nodes on the way that help filter and transform and deal with the data as it works its way towards the actual client. Now the model behind the scenes inside of our client microservice, the export client registration microservice, is actually pretty simple. This is the model that allows us to understand as some sort of client, what data you want, where you want it, how you want it. So at the center of this model, we have something called an export registration object. And that, as you can imagine, is kind of a wrapper around all the bits and pieces about what clients want. We allow them to name their registration, but then we also have them specify where they want that particular data to be sent. So one of the sub-objects off of export registration is the addressable. In a previous tech talk, we talked about what an addressable is, but essentially, where's the address, where's the location of the endpoint where you want us to deliver the data? Where do you want it in terms of an MQTT topic, or where do you want it in terms of a REST address? We also have off of export registration another object called the actual set of filters. This is a collection that allows you to specify, again, things like device IDs you're interested in or value descriptors you're interested in. In other words, the type of data you're interested in. Also hanging off of export registration is the format. This is just an enumeration. Today we support JSON or XML. No reason why we couldn't support other formats in the future. We allow you to specify what kinds of encryption details and encryption format you want us to apply to the data. So here today, the only thing we're supporting is the AES algorithm, but tomorrow we could certainly support other algorithms and let you pick that and provide more details about things like the actual credentials for encryption, or maybe the salt or whatever else is involved in the encryption mechanism. And we also support compression. So we also have to hang off this export registration, the compression information. Today we support gzip and zip formats. Again, tomorrow in the future, we could support other formats via this model. So as the message comes into, let me back up here, as the message comes into our pipe, and as we copy each of the event message readings coming off of core data, it's at that point that we'll grab the export client data, put it in that registration model, and actually attach that right to the same message, so that as it goes down this pipe and filter architecture, we have both the data coming out of core data and each client's registration details in that message, so we can use both of those to actually get the data ready for them as they want it and be able to ultimately ship it out to where they want it. Now, the API around the export gang is pretty simple. The export client API is a really basic REST resource API set. The only thing we're dealing with here are client registrations. So at port 48071 by default, you'll find export client, and you can make these calls of export client. We can register a new client interest. That's done via post. We can update any existing client request, and that's done via put. You can remove, or if you will, deregister is probably a better way to put that, any particular client request. That's a delete request. And you can get all the various registrations out of the system. We can either get individual registrations, either by name or ID, or you can get all of the registrations that are in the system with this get registrations, get request. Lastly, with all microservices inside of our EdgeX Foundry system, we do have a ping operation. This just provides us a health and status check of the export client microservices in general. It's not a ping operation on any particular registration client. The export distro actually does not have a REST API set, save one thing. It does have a ping, as all microservices in EdgeX has, but it doesn't have any other REST APIs. And that's because, again, it's the worker bee behind the scenes that takes incoming data from core data and distributes them out to the various clients. But we don't ever call on distro. It's just working behind the scenes based on whatever client registrations are made through export client. Let's take a look then at a bit more detail of how some of these client registrations work, and take a look a little bit at the detail about what's going on behind the scenes underneath the covers inside of distro. So underneath the hood in distro, as I mentioned, it's pipe and filter architecture. So you have to know a little bit about EAI patterns, have to know a bit about Spring integration to make this work. But essentially each core reading, as we've talked about, comes off of core data, gets pushed into 0MQ endpoint. Then at that point, it enters into that big long collection of what we'll call nodes, or EAI nodes, that do the transformation, the filtering, the copying, all that type of work. We're going to take a look at one of those nodes here in just a second. So after each core data reading comes through, gets copied for each of the client registrations and then pushed back into that channel, that's when each of these nodes that do the message filtering, routing, format actually kick in and do their work. Now, how do those operations actually get accomplished? That's where Spring integration is really, really beneficial to us. Let's take a look at an example of one of these. And really all they are Java beans, or more precisely, Spring integration beans that actually do this work. So I'm going to bring one into our display here. Hopefully seeing here, if you can see that, that's a little tiny. Let me see if I can zoom in on that a little bit. So what we're taking a look at here is one of those such operations, or one of those such beans that I mentioned from the EAI pipe. This one does the work to filter out based on maybe a client's choice and devices that they're interested in. All that really is required is to create this little class, in this case called a device filter, that implements one of the Spring integration EI patterns. In this case, it's a pattern called message selector. A selector, as its name implies, filters things or selects things out. That which it selects to be in a positive way, it keeps going down this channel. That which is determined not to be acceptable or filtered out are selected out of the channel. Now, when you build any one of these particular components in this EI pipe, it's a pretty simple Java object that has these implementation patterns in them. And then you'll see that they have to have at least one method in them that actually does the work of that particular node. In this case, a selector has to do the work of accepting things or not. Notice that it returns a Boolean. So the messages that come down this pipe have to be accepted or not accepted. And in this particular case, we're accepting or not accepting based on the fact of what particular identifiers, device identifiers, we see in the message. If it determines that the device identifier we are looking at happens to match the device identifiers from our client registration, then it lets the message go through and returns accepted or true. If it finds that the message coming through has device identifiers that do not match, are not part of the client's registration, then that message gets rejected. We throw a false out of that, and that particular event reading collected by a device or sensor does not go to that particular client. So you can see these nodes are actually fairly simple little components that take on a particular task in this EI pattern. And each one of those components then, put together, creates this very big and complex mechanism to get data in a format that a client wants, in a particular compressed or encrypted format way, filtered according to their rules, and then distributed out to their endpoint. By the way, too, there are other EAI technologies, and as I mentioned, the Spring integration technology, it can be a little bit fat. So we are looking at potentially using other technologies going forward. And of course, we're also looking at other languages, and so other languages have other implementations of these EAI patterns. In particular, in Java, there's another one called Apache Camel. And we're actually taking a look at that to see, well, could that be used to maybe help lighten the load and reduce the footprint a little bit? We'll have to do some more research on that, but certainly there are many, many options here. EAI is a pretty typical architectural pattern used in lots of environments. For any of you who've had to do any kind of enterprise work, you'll see all sorts of EAI, and this will be very familiar to you. It's just operating, obviously, in a very different circumstance, and that's at the edge. So again, what we're talking about is what's called a pipe and filter mechanism. In a pipe and filter mechanism, you start with some sort of entry endpoint. In our case, that's a 0MQ topic. You then go through a set of nodes, or what are called sinks, all the way down to where you have an output endpoint. In our case, that's either a REST or MQTT endpoint. In between, we have all these nodes that do work like filter, copy, what are called enriching services, transformation services, and this is what allows for the great flexibility in this export distro system that we have. We can add lots more pipes, we can add lots more nodes into this engine to allow for more capability going forward. And all they are is additions of simple little Spring Java beans to get that work done, just like you saw previously. Now, with regard to the export node, as I just showed you in that example with device filter, one thing to see as well is Spring EAI or Spring integration operates via lots of annotations. Let me bring this back into play here one more time. So not only do you have the node that's there, but also represented in this code is how you get the data in and out of that particular node. Notice that there are these input channels and output channels. That's what just dictates which node it came from. In this case, any data coming into this particular node is coming from what's known as the inbound event messages. And then it also provides where it goes after it goes through this particular node. In this case, we go through the device filtered event messages channel, which goes on further down the line to those other nodes. So inside of this Java Bean is lots of data, not only about how to get things, in this case, filtered, but also about who brings it in and where does it go after it gets taken care of. The nice part about this technology is that Spring integration is doing all the work underneath the covers. It provides a lot of the framework pieces, so you don't have to do all the work about creating these message pipes and channels. It does all that work. You just put together all these little nodes that take care of the jobs you want done. Okay, let's take a look then at how this export client and export distro work underneath the covers, how they're actually behaving when we see it running inside of EdgeX. So let me bring up a couple of little pieces here. Let me escape out on my PowerPoint here. So I have running in the background right now, I have our EdgeX system running inside of Docker. So I've got core data, metadata, command, export client, export distro, logging, notifications. I've got all those running right now inside of Docker containers running here on my laptop. What I don't have running right now is a device service. We're going to simulate device service by just pushing messages by hand right into core data. That way we can actually see things come through in a kind of a timely, synchronous manner as opposed to trying to capture data as it's coming flying off of some sensor or device. But I've got all the other services up and running. So if we then take a look at, for example, core data, and this is the little REST client here that I've got that's pointed at my instance of our various services out there. And in particular, I'm going to make a call of the core data service 48080 inside of my Docker container. And I'm going to get a count of the number of events we see inside of core data right now. And you can see that right now we have 12 events that are in there. Now, let me go ahead and get ready to post another event. I'm again going to send a message off, in this case, to, again, core data, so port 48080. And I'm going to do a post with a new reading. By the way, in prep for this call, obviously, I already set up all the metadata for this simulated device service. And in particular, what it is a human and dog counting camera. If you're familiar with our wiki site out there, it's what we use to provide a lot of the demonstration of the API. So what it does, it reports the number of humans it sees and the number of canines it sees, simulating some sort of sensor out there. So in just a second, I'm going to post a new message into core data as if I was a device service, pushing out a new human count and canine count into core data. And when we do that, we should see the number of messages increase inside of core data. So we'll see this count increase. But before we do, let's also get a client set up, a export client setup. In particular, what I've done is I've set up an MQTT client. And this is actually a cloud-based MQTT client. I've got an instance of Cloud MQTT running. Out there in the cloud someplace is one of my topics I've defined. We'll take a look at the details here of our client. And in particular, I've got a topic I call test topic. It's running out there on Cloud MQTT. And this is the information necessary to actually register that client. Yes, I know, my real password and user there. I keep doing these demos, and every time I do, people go and whack on my test facilities out there. I got to wipe them out and start all over. Part of doing demos, I guess. So we've got this client ready to start receiving data off of core data, in particular Cloud MQTT. I've gone ahead and registered that client. And we'll see that the only real difference here is to make a post call with that same data to have that occur. I've already done that. And if we actually take a look at the clients, we'd actually see that the export client now knows about that request to send all new data off to Cloud MQTT with these credentials. One thing I will have you note is I've asked to format it in XML right now. And nope, I haven't asked for anything else. I haven't asked to filter. I haven't asked to compress or encrypt, but I certainly could by these APIs. Now, if we look at Cloud MQTT, I'm set up here to start looking at the messages being received into the cloud facility. This is running off in some cloud site someplace. I have no idea where the server is, but we're actually set up to actually start to see the data come into the cloud now as it gets pushed by EdgeX. So how does that occur? Well, as soon as a message gets pushed into core data, which I'm about to do here in a second, it'll go into core data, get pushed into the export distribution service. Export distribution service will see my registration of that client to Cloud MQTT, pick up the message, do its transformation, and then send it off back to Cloud MQTT. So to make sure and prove positive that this is actually going to occur, let's change the human count. We'll make it a nice big number, like 333, and the fact that we see 43 dogs. So I'm going to make that post now. Now remember, there goes, it just sent that message. Now remember, we saw earlier that I had 12 events in there. If I re-get that, we'll see now there's 13. So we know the message made it to core data. And now let's go out and take a look at that cloud system. Here we go. Cloud MQTT has received a new XML message. This is one of our EdgeX messages working its way through export distribution, and proof positive of that, if we take a look at the data, we see that it actually pushed the 43 dogs that it saw and the 333 humans that it saw formatted in XML off to Cloud MQTT. You could just as easily have it sent out to Azure, send off to your application enterprise systems, whatever the need might be. Now again, export client allows us to make changes to that and to add additional clients. Let's just show you a real simple case. Let's change the format that we want to receive the data, not to XML, but let's make that JSON formatted. I'm going to make a put request, which just does an update of that client registration. It says, yep, I got that. Now let's go send another message. Let's say, well, now we only saw one human, but that one human has got, 5 dogs with them. So we'll push that message out. Again, if we look at the client core data, we see 14 messages. And what happened up in the cloud? Aha, that new message got arrived into the cloud again, this time in JSON format, not in XML. And no, it wasn't a copy of the old message. It's that new message. We can actually see that it saw the 5 canines, and we could see that it saw the 1 human out there as well. So that, ladies and gentlemen, is our export distribution service and our export client service working in tandem to allow data coming out of EdgeX through core data to be distributed up to clients as they request. Demo gods were with us one more time again, lucky us. So a couple other things we want to chat about here before I open up for your questions here. So the export services are being relooked a little bit as the application working group kind of peels in and hardens them up. They're also taking a look at some additional requests that were made in our first face-to-face meeting as a technical group back in London in July. In particular, they're looking at adding a few things. First of all, they're looking at adding a capability in the distribution service to develop a map for a client that says, I want these devices to be sent to this topic in MQTT, or in other words, to a particular endpoint. I want these other devices to be sent to this endpoint. And the reason we're doing that is we found that many of the cloud providers, your Azures, your IBMs, your Google, those cloud IoT providers want data coming in on a particular channel to a particular topic per device ID. So we're trying to meet that need in a little easier fashion by adding some capability both to client registration as well as to export distribution that says allow clients to make those kind of registration requests and then allow our distribution service to spray the data coming through to the appropriate topic based on device ID. So that's change one we're looking at. The other change we're looking at is adding additional endpoint support for MQTTS, so in other words, secure MQTT pipes, as well as HTTPS, so secure REST client endpoints as well. So we hope to have those in the Barcelona release coming up here in October. There are a few configuration options that I'll just mention with regard to export services, both the client and distro. With regard to our export client service, there is a facility through our notification and alerts microservice that every time you register a new client or you deregister a client, it will send off an alert and notification message to whoever might be registered for those messages. The idea behind that was to both demonstrate alerts and notification, but also the thought process was there that could be a bit of a concern if all of a sudden you either have lots of clients or maybe you've got these clients you've never heard of before and trying to figure out, why are they registering for my very sensitive sensor data. So we have that alert notification option in there, and there's some configuration to help set that up. We also have typical Mongo configuration options in there. Anytime you have to deal with the database, as the export client does, it needs to know where the database is and how to connect to it. And then there are standard configuration options you'd see there for almost any of our EdgeX microservices. For example, what port should it run on? What are the log levels? Things of that nature. On the distro side, we have to connect up to the core data's 0MQ topic. So there's information there about how to, or configuration information in there about how to get that set up. By the way, too, if you don't like 0MQ, if you want to use something like ActiveMQ as your pipe between core data and our distribution service, you can do that. We chose to use 0MQ by default because it was lighter, but there are options to use a big MQTT broker. You just have to provide the broker, and usually there's more setup and a little bit more cumbersome activity there with regard to getting that onto the EdgeX platform. There are also options out there in the configuration mechanism for export distro to determine whether or not you want to do a value descriptor check or whether you just want to accept the data and you're not really concerned about some of those checks. This is what allows us to filter out things like data that doesn't match up to what you said was going to be the parameters for the data. Maybe you said the thermostat reading should be between 0 and 100. All of a sudden we get a thermostat reading that says 120. Should we ignore that or not? That's what the value descriptor check brings into play. Other configuration options in there, again, Mongo database configuration, because it has to pull out the registrations out of Mongo, and then the standard configuration options for all services, again, things like ports and log levels. Gang, that's export distribution and export client, what we call collectively the export services. Coming up in some weeks to follow, we're going to be talking a little bit about the device services and in particular how to start to think about building your own device to service with the device service SDK. We still have the rules engine to talk about, so we'll talk about the rules engine microservice, which is typically at the tail end of this export services, one of the clients of the export service, as a matter of fact. And we could talk about some of the supporting services, logging and alerts notification being a couple that you can use to your disposal to get log data out and again to do things like alerts and notification, which as I mentioned what the export distribution service might use, or I'm sorry, export client might use to let you know when a new client is getting data out of your core data system. With that, it is time for your questions. All things EdgeX related, don't have to be about export services. Let me kind of quickly go to our chat window here. We do have one question already from Rodney. The APIs seem to be rather hard-coded. In other words, protocol is an enum. Is there any interest in more of a dynamic interface where the export distribution service can advertise that it supports, say, a particular protocol like non-MQTT, or any export client service would allow registrations for that new service? You're right, Rodney. Certain things are more prescriptive, not if you will, dynamic. A lot of that has to do with the fact that we have to, inside of things like the EAI pipe, we have to be looking for certain things. We have to be looking that you have a need for transformation, and that's either JSON or XML. So if we start to make that dynamic, that would require those distribution services to also be much more dynamic, and we could certainly do that. We could certainly start to add lots of facilities in there that makes that much more dynamic. That code base starts to get larger and larger. So it's one of those options we're going to have to kind of consider very, very carefully. You know, how much flexibility do you provide versus how much do you provide for getting this data off and to the cloud, where at the cloud level, more things might occur. our feeling was kind of that we needed to provide minimal support to get information off into a format that would at least be accepted by a cloud or enterprise application. And from there, once it gets to a big data lake, bigger engines and bigger systems could start to do a lot more transformation and EAI work on that. But it certainly avails itself to that. So if people have interest to building more complex engines that are a little bit more dynamic, and if EdgeX finds itself running in systems that avail itself to a lot more memory and processing capability, that is certainly an option to look at. So good question, Rodney. Other questions that we might have out there? The silence is deafening and overwhelming. We have bowled you over with integration engines and talks of registration clients, all sorts of stuff out there, gang. This is a pretty neat service, gang, and I will tell you, having spent a lot of my career in doing enterprise development, this engine is an impressive one. That is by Spring and this integration engine, but again, there are other options out there. It is a very powerful mechanism. We do think, too, kind of going in the opposite direction from Rodney's question, we do think, too, there might be a need in the future for maybe simpler export services, ones that maybe don't have quite as many options. If you are in complete control of your EdgeX systems and they're out there on a farm of gateways collecting data from thousands and thousands of sensors, maybe all you're interested in is getting them into the format that can quickly get to the cloud, and at that point you'll take it from there. So we could see an export service that actually is quite a bit trimmed down. In fact, the very first instance of Fuse we built, we did nothing other than get it into JSON format so that it would avail itself to enterprise systems. But we've added more capability to provide some of the needs we see in edge systems that say you can't send all the data to the cloud. That's just going to get to be too expensive. And you may need to send it to multiple clients because you have various clouds or various applications that need the data. So we need a little bit more of an expensive engine, but there is always the balance here, and that'll be trade-offs you'll have to include in your thought process of incorporating EdgeX into your systems. Any other questions, comments, concerns? Ronnie, yeah, one more question. Can more than one export distribution service run? Yeah, all of EdgeX is built to be essentially scalable. In fact, that is one way we think we could address having multiple or more than what I would consider to be a nominal set of clients. You could essentially just farm that out to multiple services. One thing to consider with that is now we have to think about, well, how do we essentially load balance the data coming out of core data to those multiple instances? There's nothing in the distribution service or export client that says we couldn't have multiple. The question is, how do you then spray and load balance it to the multiples? So there'd have to be something between core data and the export services that figures out how to do that load balancing. Be pretty easy to actually put a load balancer of some sort in place between the two, but that would be a technical and architectural question you'd have to address before you do that. But absolutely what we were thinking there is any service, to include these two services, Rodney, should be able to be distributed and have multiples. Any other questions, comments, concerns? Alrighty, folks, I will take the silence as clear and good to go. Give you a few minutes back of your day here, or as it is about 5:50 here in the Central Time Zone, it is drink time for the cocktail. So thanks, everybody. Appreciate your time today. Hopefully you found this information useful, and we'll speak to you soon on some of the other Tech Talk coming up.